Question 11. The complex number minus 3 plus I is denoted by u. A. Express u in the form r times e to I theta, where r is greater than 0 and theta is between minus pi and pi, giving the exact values of r and theta. So basically r is the modulus and theta is the argument. R is root 3 plus 1, which is 2. U is in the second quadrant, so theta should be pi plus the inverse tan of minus 1 over root 3, which is 5 over 6 pi. Here, because U is in the second quadrant, it needs to be an obtuse angle in here. It should be 5 over 6 pi. B. Hence show that u to 6 is real and state its value. U to 6 is r to 6 times e to I 5 theta. So it's 2 to 6 times e to 5 pi theta. 6 times of 5 over 6 pi is 5 pi. So it's 5 pi I. 2 to 6 times e to 5 pi I. 2 to 6 is 64. 5 pi falls on the x minus axis. So it's equal to e to pi I. That is minus 1. That's minus 1. 5 pi and pi, they fall on the same arm, and it's minus 1. So u to 6 is minus 2 to 6, which is minus 64. It's real. C1. On a sketch of an argon diagram, shade the region whose points represent complex numbers z, satisfying the inequalities arg z minus u is between 0 and quarter pi inclusive, and the real part of z is less than or equal to 2. So the arg z minus u is between this. That should be between two half lines. This is u. U is minus root 3 plus I. It's in the second quadrant. When the arg z minus u is equal to 0, it's this half line. When it's equal to half pi, quarter pi, it should be this half line. And this angle is quarter pi, or 45 degrees. And it should be the region should be between these two half lines. And real part of z is less than or equal to 2, should be this vertical line is real part of z is equal to 2. Less than 2 should be to the left of this line. Therefore, the shaded region should be this right angle triangle. To find the greatest value of z's modulus for points in the shaded region, give your answer correct to 3 significant figures. Z's modulus should be the distance of the origin to the points within the shaded region. We can see that this point marked with the red cross has the greatest value of z's modulus. In order to find z value, we need to find its x and y, or real part, and the imaginary part. The real part, we know that's easy. The real part is 2. So this is 2. And the imaginary part, we know this is 1, right? But how about this This is a right angle triangle and this is 45 degrees. So this vertical side should be equal to this horizontal side. And the horizontal side is, this is 2, this is root 3, so it's 2 plus root 3. Therefore, this vertical side is also 2 plus root 3. So this entire, or the imaginary part of z, or the y coordinate of z, is 3 plus root 3. This is 1. This is 1. So z's modulus is the root of 2 squared plus 3 plus root 3 squared. Using your calculator, you can find it as 5.14.